everyone. We're going to look at example 2.13 in your notes. And you should have looked at the rules for series circuits by now and reviewed them. So the things you need to remember is the voltage across each resistor. It's called a voltage drop. We'll get into that later. The voltage across each resistor. So I've gone ahead and drawn the circuit here. The voltage drop across each resistor equals the total voltage from the source. So whatever voltage drops have to get down to 0 to go back to the 12 volts that are here. The current that goes through the circuit, all of the current that leaves the battery is equal to the current that goes through this, which equals the current through here, the current through here, and the current through here. That's because the current is all the charges, and there's nowhere else for the charges to go but in this one actual loop. And the equivalent resistance, which is basically what resistor would replace all of these, is equal to each of these resistors just added in straight algebra. So draw the circuit. I've drawn the circuit. You can put all of the R's along the top, make a long skinny one. You could make it narrow and a long one down this way vertically and put them all on the side. You can spread them out. I like them spread out so I can put them on the diagram and show you where they came from. So first up, draw the circuit. Second, find the REQ. So the REQ is simply, as we just said, R1 plus R2 plus R3 plus R4. If you're doing this, you should show where it came from. You shouldn't just show a number there because it doesn't explain where it came from. So R1 is 2 plus 6 plus 4 plus the 3 in the bottom. And sometimes they add up nicely and sometimes they don't, but these ones do. This is 15 ohms. So I put REQ over here. So it goes with the battery. I work with it as one thing over here. So REQ is 15 ohms. So I'm going to erase this part right here. And I'm going to find the source current. So as long as I have a voltage and a resistance for one thing, either the battery or any resistor, I can solve this. So I'm going to do it this time just for the source, but I don't really need to do this every time we do it repeatedly. So right up here it says use V equals IR for each resistor. Do the same for the battery. So that's 12. That's I from the source. And this is 15. And doing the math, current from the source equals 0.8 amps. So that current is the current through here, which is also then, as we remember, we said the current's the same all the way through. So that's 0.8 amps. So we've gone ahead and filled this in. So the current is the same all the way through. So 0.8 amps, and those are 8s, not 3s. 0.8, 0.8, and 0.8. So the current stays the same all the way through. And because of this equation, V equals IR, I can then find the voltage through each of these. And when I'm done, they should all add up to the total of 12. So I'm going to do that quickly. I've gone ahead and done V equals IR. So I times R, 0.8 times 2 is 1.6. That's 4.8, 3.2, and 2.4. They should all add up. So 3.8 and or 3.2 and 4.8, sorry, are 8 volts. And these two had to give you 4 more. So that will be a total of 12 volts. You can add them to the side, but I trust you to add these. So really, all I need to show is the REQ if I'm finding it. So I've gone around. Now you can put them all on the table on the side, but I find this way it's just as easy to actually be able to go around, check my stuff. The current's the same all the way through. That checks the voltage, all adds up to give me a total of 12 volts. Hopefully that makes sense. And you can do the other ones. If you look at the other questions, sometimes you have a voltage and a resistance for one spot, or the voltage and a current. You can find the resistance. If you have any of these two pieces, you can find the missing current and then put it all the way around and solve these questions. So hopefully that makes sense, and I'll help you with the other questions. Thanks.